All right, hi kids. So I'm not sure if we've already done one of these. I think you did, but I'm not here, so you're gonna take notes and go through this. So I'm gonna give you a couple seconds to start on the warm up. All right, go through it. When you're finished, um, hit pause and hit play, and then you can kind of see and make sure that your warm up answers are the same as mine. All right, so pause it and then play it when you're done. All right, so here we go. I'm gonna first apologize because I'm trying to type this and none of the stuff is working and I'm kind of off. So if it's a little messed up, please forgive me. Anyway, number one, it says what part of the quadratic function indicates whether the function will open up or open down? And that is the a value. All right, remember when a is positive, all right, it opens up, all right? It opens up like a smiley face, like a positive person. If a is negative, it opens down. All right, like a frown, like a sad person. Okay, so when A is positive, it opens up. When A is negative, it opens down. And remember, A is that first term, and y equals ax squared plus bx plus c. All right, your A value, all right, your A value tells you whether it opens up or down. Now, number two, find the vertex of the function f of x equals negative 5x squared minus 18. All right, so first off, it says, do we have a minimum or a maximum? Well, our A value, all right, is negative 5, which means it's going to open downwards. So our vertex is going to be a maximum. All right, so you can write max or maximum. Now, what is the vertex? So our vertex formula is, so it's a coordinate, so it's x equals negative b over 2a. So you got to take the a and the b. So if you look at this function, your b value, there is no b value because your b value is connected with the x. There's no b value, so it's 0 over, well, it's negative 0 over 2 times a, which is negative 5. Well, here's the deal. If your numerator is 0, your entire answer is just going to be 0. So my x value for my vertex is 0, but what's my y value? So once we find our x value, you take your y value, all right, you take your x value, and we're going to substitute it in. So we're going to go f of 0 equals negative 5 times 0 squared minus 18. Well, 0 squared, this is all just going to be 0, so your y value is negative 18. That should be a negative sign. So it's 0, negative 18. Now, your axis of symmetry. So your axis of symmetry goes through your vertex, all right, and it goes through the y value of your vertex. So it's just going to literally be this. It's going to be y equals negative 18. So once you find your vertex, you found your axis of symmetry because it's a vertical line that goes through your vertex, goes up and down through your vertex. Like if this is my vertex, my axis of symmetry splits that. Your y-intercept. Now your y-intercept is always your constant, so it's going to be 0, comma, negative 18. That should be a negative. Again, I'm sorry, the board's a little funky, so it's 0, comma, negative 18. And then your x-intercepts. Now your x-intercepts, you're going to have to use your calculator here. All right, so we're going to need to use our calculator. All right, so you got to type this in. All right, and you're going to need to figure it out from there. Oh boy, this isn't working. All right. Hold on, I'm going to have to do it on a separate calculator. So you're going to have to type this in, all right, and you're going to have to figure it out. This may be fun today. Here, I'll do it straight from here. There we go. Let's turn this thing on. All right, so we're just going to type in the third one. Turn that off. Turn that one off. I was trying to be productive here. Clearly, it's not letting me. Here we go. There you go. I want to use this one. So we're going to do negative 5x squared minus 18. All right, so now what does this thing look like? So here we go. It's really difficult to see, so I'm going to make my window. I'm going to make my window a little bit bigger. I don't really need to see more x as I can. I'll put that at negative 5. I'll put my x max at 5. What I really need to see is more y values. So since I know that my axis of symmetry is at negative, my vertex is at negative 18, I'm going to make my y minimum negative 20. All right, and we know it's opening downward. All right, so we're going to make our max 0. So let's go back and let's look at this thing. Come on. Did I type this in right? Why isn't that showing up? I don't know why. Oh, I know why. Here we go. Let's go down here. Yeah. Stupid Mr. Kwame. So this is the difference. You don't want to use the negative. You got to use the minus sign. So here's our graph. It should be somewhere down here. So now notice, do you see any x-intercepts up here? No. So we would write none. And I'm using my mouse for that, so that's awesome. So none. Lovely. All right, so what you should do now, okay, you can check your answers for homework last night on Google Classroom, but right now we're going to get started on our lesson today. So let's get started. Now today's lesson is really just taking an extension of yesterday and, well, seeing what we can do here, all right, doing it in a real world. All right, so here we go. It says a frog can hop, or sorry, a frog is about to hop from the bank of a creek. The path of the jump can be modeled by the equation h of x equals negative x squared. So this is your frog right here. This is the frog. Oh, God. Okay. Of course. Come on, man. Are you serious? This is terrible. This is absolutely terrible. Anyway, there's your equation where h of x is the frog's height above the water and x is the number of seconds the frog has jumped. All right, so x is your time. All right, y is your height. So y is your height. All right, so y. All right, so y equals height. All right, and x equals time. So it's important that we understand that x is not distance, like the distance he jumped, it's time. How long was he in the air for? All right, so, okay. Where am I at? A fly is cruising at a height of 5 feet above the ground, so it's just floating above the ground. All right, now it says, is it possible for the frog to catch the fly, given the equation of the frog's jump? So here's the deal. All right, basically what the equation is saying. All right, you got a frog, all right, chilling on the creek, and he's going to jump in the air. All right, there's your frog. He's a turd, lands here. All right, starts here and goes and gets it. Now, there's a fly, all right, there's a fly just chilling somewhere here. What we want to see is, will the frog eat the fly right here? Will it make it to this spot? So what we want to do is we're going to need to figure out what the vertex is of this equation. That's what we're going to need to do. Find the vertex of this equation, and we will be able to determine, does it hit its maximum height at 5 or more? If it doesn't, it's not going to touch it. So what we'll do is we'll find the vertex. So vertex, here we go. So we're going to go x equals the opposite of b over 2a. All right, so in this equation, the opposite of your b value is going to be negative 4 over 2 times negative 1. And negative 4 is going to be in your numerator. Come on, negative 4 over 2 times negative 1 is negative 2. Negative 4 over negative 2. So my x value of my vertex is going to be positive 2 because negative 4 over negative 2 is positive 2. Now, what we do is we now take this 2 and we substitute it into our equation. So we're going to go f of 2 equals negative parentheses 2 squared plus 4 times 2 plus 1. All right? And what you're going to do is you're just going to simplify this. So negative 2 squared is going to be negative 4, and the reason being is 2 squared is 2 squared is 4, times negative is negative 4. 4 times 2 is 8, and then plus 1. So negative 4 plus 8 is 4, plus 1 is 5. So our y value is 5. Now, think about this vertex. At 2, 5, he is at its highest point. Now, what 2, 5 means is it means at 2 seconds, he is at a height of 5 feet. So here's my question. Will the frog catch the fly cruising at 5 feet above the ground? And the answer is yes, it will. So we've actually figured it out. Now we just have to model this. All right, so now we have to model it. We got to graph this thing. So, all right, what we're going to do is we're going to graph our information right here. Now, I am going to, all right, label. All right, so my y value is height. All right, my x value is time. All right, now, here's the deal. I'm going fast. If you're like, holy cow, this guy's flying, pause the video. Pause, all right? I don't have much time to do this, so I'm speedy, all right? You can pause. Now, back to this. So we're talking about height. Now, clearly the frog can't be in negatives, all right, negative height. So we're going to start at 0 down here, all right? And it's our choice. We know it's going to go up by 5s, or up to 5 feet. So I'm going to make every 2 boxes 1. Oh boy, 1. Oh, it's hard to do this when it's not center. 2, This is 3. Oh boy, this is gonna suck. 4 and confuse the hell out of you. And 5. There we go. And our time we're gonna do in seconds. All right. So oh my God, I gotta have be down here. 1. And notice I keep splitting them. Oh, jeez. 2, 3, 4, and then 5. If you could see me right now doing this, it's ridiculous. I'm sorry for how crappy this thing looks. All right, anyway, so what we need to do is we need to graph all the information here, which is going to be even more fun. All right, so I'm going to start with my vertex at 2, 2, 5. So that means at 2 seconds, all right, he's 5 feet. So let's see, where is that bad boy going to be? No, where do I got to be? Oh, okay, that's how we go. So that's our vertex, all right? So this is 2, 5. Now, we know that the fly is chilling at a height of 2. So here's the fly. It's just chilling right around here. We know that the fly is going to get eaten. We've already discovered that. We've already figured it. We just now need to graph this thing. So we need a couple important points, all right? We need our y-intercept. So we need our y-intercept here. So if you look at this problem, what is the y-intercept at this problem? Well, your y-intercept is your c value, which is 1. So our y-intercept is 0, 1. So we need to graph that. 0, 1 is right, no, where is it? Right there. Holy cow, I did it. All right, so that's your y-intercept. Now, check this out. All right, we talked yesterday about axis of symmetry. Well, if we know where our vertex is, all right, which we found our vertex, we can draw our axis of symmetry going down our vertex, and that's going to give us a symmetrical point for the y-intercept because we want to make this as nice as possible. So what we do is we count from our vertex, or we count from our y-intercept how far away it is from the axis of symmetry. It's 1, 2, 3, 4 boxes. So we go 1, 2, 3, 4 boxes here, and we put our other point. So we can already kind of see what our parabola is going to look like. Oh my gosh. All right. We already know it's going to do something like this and then come back down, but do we know where it's going to land? Do we know where this guy is going to land? Because clearly he's got to get back to the ground, all right, at 0 to land. So what we have to do is we have to use our calculator and we have to figure out what its y or x-intercept is. So what we're going to do is take out our calculator. What is this? Where's, good God, what did I do? There it is. All right, sorry. We've got to take out our calculator, all right, and we need to type in this equation, all right? So I just go always second plus 712. Clear my calculator. So I go y equals, I believe this is negative x squared. Shoot, I can't remember. What is it? Negative x squared plus 4x plus 1. All right, so negative x squared plus 4x plus 1. So this is what our graph should look like. Hey, look at that. There's the frog. All right. All we're really concerned about in our graph is we're doing this first quadrant. But we need to find that x-intercept. So how do we do that again? So what we do is we go second, and then we hit the trace button, and that's going to calculate. So what we want to do is we want to calculate the 0 value. 0 is talking about x-intercepts. So we want to find our x-intercept. Now, here's the deal. The calculator will tell you how to find it. You just have to be smarter than the calculator and put the points in the right spot. So there are 2 x-intercepts here. There's this one and this one. I don't care about this one. That's a negative time. I don't believe in negative time, neither do you. So we're looking at this one to the right. So I'm going to move this thing all the way to the right, but I want to stay on the left side of my x-intercept. So I'm on the left side, hit enter, and now I'm going to go to the right side. So I'm going to go below it and hit enter. Now the calculator says guess. I don't ever guess. I just hit enter and it will find it for you. So our 0 is 4.236 and our y, now look at this, 1e to the negative 12. That means 0. So it's 4.236 and then 0. So 4.23 is somewhere around here and we just go here. So we say our x-intercept, all right, is 4.236, 0. Some of you are like, Mr. Qualman, don't we round to 2 decimals? Yes, but I want to be accurate, especially for this problem. So there we go. Look at that. So we answered the question before we even graphed it, but we graphed it to show, hey, this is what's going to happen. The fly is going to chill here. The frog's going to eat it because it gets to a max height of 5 feet. Cool? Awesome. Here we go. Go to the next one. All right, the next problem says, Tom and Jerry are at their local swimming pool. They want to jump off the 12-foot diving board to reach a distance of at least 20 feet. So we want to make sure that they get to the 20 feet mark, all right? Tom's jump can be represented with a function of t of this guy, while Jerry's jump can be represented by this guy right here, where x is the distance in feet from the diving board. Do Tom or Jerry make the distance? If so, by how much? So here's the deal. What we want to do is we want to find the x-intercepts. This is what we're saying. We want to say that he jumps at least 20 feet. In this problem, x equals distance. And so will y. Y equals height. Okay, so what we're going to be doing is we're going to want to find our x-intercepts. Now, here's the deal, all right? We can actually do this without graphing first. We could figure this out mathematically, all right? What we can do, all right, in your calculator, go second plus 712, and what we can do is we actually can type in all these equations. Type them in one at a time, all right? So I'm going to go parentheses. Now, remember, anytime you put a fraction in your calculator, you got to put parentheses. So parentheses 1/3 x squared, all right, plus 2x plus 12. Now, this is your Tom jump. So we can see, we want to see, does each one make it? Let's see. So here we go, graph. All right. And notice, oh, you can see something. Now, here's the deal. We can already answer this. We can already answer this question because in the window, all right, notice my x max is 10. This is a standard 10 by 10 window. When you reset your calculator, it's a standard 10 by 10. I can see in the graph that Tom, I can see where it lands. It's definitely before 10. So I know Tom is a no-go. But in all math classes, you have to give me evidence. So I want to know exactly where that x-intercept is. So I'm going to go second, trace, and I'm going to go down to 0. Now notice, I do this one at a time. Why? If you put both equations in there, it's going to get very confusing. All right, so here we go. So it says x is 0, y is 12. So that means we're on the y-axis. So I'm going to go closer to the right. I like seeing the seeing that x value, that little clicker thing. You can see my guy going. All right, you don't have to be. You could have hit x, enter right away, but I just like to be close just so I know that I'm there. And I want to go underneath it and hit enter. And what is the x-intercept? 9.7. So did Jerry jump 20 feet? So Tom is a no-go. Tom equals no, because his x-intercept is, what do we say, 9.7? Oh man, he didn't even come close to that. Comma 0. All right, now let's check Jerry. All right, so in our calculator, you could reset it, or I didn't mess with the window, so I just clear it, and I'm going to take Jerry. So I'm going to go parentheses, negative 1/16 x to the second power plus x plus 12. So here we go. Ready? Let's see. Now, if you look at Jerry's jump, Jerry's graph already looks different because you can't see that part of the parabola coming down. So let's take our window and let's extend it to our x max, and let's see. So I don't want to go to 20. I'm going to go to 30, and let's see if the graph comes down when I extend it to 30. Hey, there it is. Now extended. Now here's the deal. You can say, yeah, that looks like he probably jumped it. That's not good enough. I need evidence. So we need to go second, trace, and I want you to find me the 0, the x-intercept. So I want this x-intercept. How far did that dude jump? So I'm going over. Man, look at that. Now, some of you could probably look and say, Mr. Quammen, I actually could basically estimate that we're not even on the x-intercept. I'm there right now. This isn't it, but I'm already 24 feet. Perfect. So we already can say Jerry's going to make it, but at what feet? How far did he make it? So I'm going to go left of my x-intercept. I'm going to go right of my x-intercept, and I'm going to hit enter. So Jerry actually jumped exactly 24 feet. Holy cow. That little mouse jumped 24 feet. So Jerry is a yes. And his x-intercept was 24 feet. So 24,0. Now, here's the deal. The question says, do either Tom or Jerry make the distance? If so, by how much? Well, Tom, no. Jerry, yes. How much did Jerry jump that? So he overjumped. jumped by 4 feet. Now, all right, I apologize. I'm not going to graph this, partly because I'm writing with a mouse and it's terrible, all right? But it would not be a bad idea for you to go through this and graph on here your 2 images. Now, it does not say graph this and do it, but it wouldn't be a bad idea to practice graphing these things out, okay? Wouldn't be a bad idea. I'm not going to do that. I just wanted to kind of go through this and show you and kind of remind you how to find your x-intercepts using your calculator, okay? So here's the deal. So that's what you did today. Those are your notes. Here's your homework. You're going to do worksheet 211. So you're going to go up and ask the sub, can I get the homework? I'm done with the notes. And you're going to get started. All right. This is what the homework looks like. All right. It has a couple of real world questions. Notice no graphs here. So you need to figure it out. You need to use your calculator. You need to show your work. Okay. The backside again, just again, going through the stuff and 2 real world problems. Again, no graphing. Use your calculator to show your work, all right? You should be able to do this really well. I'm going to put the answers to this, and the answers are already there from the homework from last night on Google Classroom. Please check your work. If you are not understanding this, I will be in school Thursday, and we can go over this, all right? This is important. You need to make sure you know how to do this, because if you can do this, the rest of your graphing experience is going to be really, really sweet, okay? Thank you. Please be kind to the sub, and please make sure you do whatever they say, all right? Have a great day. Bye-bye.